This video is on integration. Integration is the reverse process of differentiation. When using integration, you are finding the antiderivative, and antidifferentiation is also known as indefinite integration and is noted with an integral symbol, which is that long kind of S shape. So within that, you'll see there's lots of different words that get used for integration. We've got integration, antidifferentiation, we're finding the antiderivative or finding the integral, lots of different words that you will hear within this topic. Here is kind of the formula and notation for it also. If we have the integral, so the long S shape of f of x, which we call the integrand, so that's the function that we are integrating, dx, that the d tells us that this is the derivative, and then the x is, we need to do the integral with respect to x, so x is our variable. When we work this out, we've got a capital F of x, which is our original function, plus c. Now c is the constant of integration, and sometimes we can find it if we've been given some more information in the question, which we'll do in the next video. But for now, we just have to write a plus c, and the reason for that is, if you think about when we do the derivative of a function and we have, say, a plus 3 at the end, when we do the derivative of that, that just becomes 0. So when we're going the reverse and doing the integral, we don't know if there was a constant there or not. We don't know if there was a plus 3 or a plus 5 at the end of the equation. So we write the plus c to represent that there could be another value there that we just don't know about right now. Now, integration rules, there are a lot here. I'm not going to talk through them, but you can have a quick look, write them down, take note of them, but these are all the main ones that you will need to use at some point. And we're going to be using all of these in the examples that are coming up. Our first example is we're going to be doing the integral of x to the power of 7 dx. Now, we're going to be using the top rule that is on the screen right now. This is the basic integral rule that you will more than likely use the most often. What we need to do is we're going to do 1 over, and then we do our power, which is 7 plus 1. Then we have the x, and then we do the 7 plus 1 in the power here, plus c. Now, remember here, we've got plus 1 in the power because when we do the derivative, we minus 1. So when we do the integral, we have to plus 1. And then we simplify, and we'll get 1 over 8, x to the power of 8, and always remember the plus c. The great thing with integration as well, though, is that when we get a solution like this, 1 over 8x to the power of 8, I could check if that is correct by just doing the derivative of that. If I do the derivative and I get my x to the power of 7 that I started with, then I know my integration was correct. Part B, the integral of 6 du. One of the important things here is to note that our variable is u, not x, so always check that. And if we do this, nice and easy, we just have a number, so when we do the integral, we just add the variable to the end and the plus c. Now, if you think about it, we do the derivative of 6u, we would just get 6. So therefore, we know it is correct. So nice and easy with a constant, just add the variable next to the number. C, the integral of 2x cubed dx. The 2 out the front just stays there, but it's going to be 2 multiplied by, and then we do our integral, so it'll be 1 over, the power's 3 there, so it'll be 3 plus 1, x to the power of 3 plus 1, and then plus c. And so this will give us 2 over 4, x to the power of 4 plus c, which nicely simplifies down to a half, x to the power of 4 plus c. Next, D, the integral of 4t cubed plus 6t squared plus 3 dt. When we've got them separated down pluses and minuses, we just do each part separately. What I'm going to do with this question is I'm going to do the first one, the first part of this, the 4t cubed, in a bit more of a stepped out process. 6t squared, I'm going to simplify it slightly so you can see a different way you can approach it. So 4t cubed would be, we leave the number at the front, multiplied by 1 over, add 1 to the power, so 1 over 3 plus 1, and then t, and then add 1 to the power here, so 3 plus 1. Now what else we could do with this is we've got 6t squared. So the integral of this, rather than doing 6 times 1 over, we can just do 6 over, and then the power number, which was 2, plus 1, t to the power of 2, and add 1, plus constant of 3, so we just add the t there and then plus c to the end. Then we can simplify this. 4 over 4 t to the power of 4 plus 6 over 3 t cubed plus 3t plus c, which simplifies down to t to the power of 4 plus 2t cubed plus 3t plus c. E, the integral of x squared plus the square root of x dx. Now first of all, with this one we're going to rewrite this without the square root because it makes things so much simpler, which would be x to the power of a half dx. Now we can do the integral. X squared will become 1 over 2 plus 1, x to the power of 2 plus 1, plus 1 over a half plus 1, x to the power of a half plus 1, and then plus c. And then we can simplify this, and we'll have 1/3 x cubed plus 1 over 3 over 2, which will be 2 over 3, x to the power of 3 over 2 plus c. Now with this one, I'm going to show you some ways that people do integration, and you might see in places is that we can write that this also equals, because the 3, this would be the same as 3 times 1 on x. Now what you will sometimes see is, and you don't have to do this, is that people might write that constant, that 3, out the front and write it that way instead. You don't have to do it that way, it's just a way sometimes people do it to be able to separate out the unimportant parts from the important parts of the integral and then put it all back together at the end. And now with this, it's knowing that the integral of 1 on x would be ln x. So think about your derivatives and what they were. So derivative of ln x, 1 on x. So obviously when we anti-differentiate, it goes back. So this one would be 3 times ln x plus c. So obviously just 3 ln x plus c. Next one, we've got the integral of e to the power x over 5 dx. Now this is the same as 1 over 5 times e to the x. So once again, what you could see is people write it this way. You don't need to, that is a choice you make. Now we all know that the derivative of e to the x is just e to the x, so the integral is also going to be the same. So with this one, the actual only thing we need to do is add a plus c to the end. H, the integral of 2 sine x minus cos x dx. Integral of 2 sine x would be negative 2 cos x. Minus cos x would give us minus sine x plus c. Once again, just going to the rules from before and using them in our integral. I, the integral of 2x squared plus 3 all squared dx. Easiest way with something like this, personally, I think is actually just to expand the brackets, which would give us the integral of 4x to the power of 4 plus 12x squared plus 9 dx. And then we can just easily do the integral of this. 4 on 4 plus 1, x to the power of 4 plus 1, plus 12 on 2 plus 1, x to the power of 2 plus 1, plus 9x plus c. And then we can simplify that, which will give us 4 on 5, x to the power of 5, plus 12 over 3, which is 4, x to the power of 3, plus 9x plus c. Now that second step there where I do have the plus ones and things in, you don't need to write that out. Once you've done a lot more practice with these, it'll just become more fluid and you won't need to do that step. J, the integral of 4x squared plus 2x plus 3 all over x dx. Once again, we want to simplify this. Now the easiest way, in my opinion, to do this is to separate it into separate fractions. Simplify this, we'll have the integral of 4x plus 2 plus 3 on x dx. Then we do the integral. We'll have 4 on 1 plus 1, x to the power of 1 plus 1, plus 2x. Now 3 on x we did in part f. You can see there that becomes an 3 ln x when we do the integral. And then our plus c, and then simplify. So 4 over 2 will just give us 2x squared plus 2x plus 3 ln x plus c. And then k, the integral of ln of e to the 4t dt. With this one, the first thing we need to remember is that the ln and the e cancel out, so this will actually just end up being the integral of 4t dt. And then we do the integral of that, which would be 4 on 2 t squared plus c, which simplifies down to 2t squared plus c. And that is the basics with integration.